Welcome back to Computer Graphics and Visualization subject. In that subject, we were discussing Module 5. In Module 5, we are discussing input and interaction. Already 2 sessions I have covered on input and interaction. Now I am going to cover third session on same topic, that is input and interaction. In last session, we were discussing picking device, right? How logical picking device means if I pick any icon on my monitor, then how that will, what that returns, then how to process that that part of picking. Means picking is nothing but when you are selecting something on your monitor by using a mouse, that part only you want to select, display in your monitor, right? For example, if I select, if I select like this, then whatever square, rectangle, whatever square or whatever circle I'll pick, only that part of the objects, whatever comes in that part. That, for example, if I do like this, then whatever object comes, for example, calendar, mail, Microsoft Edge, only I want to see those. At that time my viewport has to display only that much, but now it is displaying entire monitor, right? At that time whatever area I have picked, only that it has to display, right? That is called picking, right? Then how to do that one, right? That we are discussing. There are 2 methods in a picking. One is selection, then bounding boxes. So one is the selection method, one is a bounding box method. Among that, first one will select selection mode. Selection mode functions continued, right? Using selection mode, if you are using selection mode for picking, then what all we have to do? That is, one is initialize a name buffer. First initialize a name buffer, because whatever picking objects you are selecting, those all will go into name buffer. Enter selection mode using mouse. Enter selection mode using mouse, right? Then selection mode means you have to select area, then render scene with user defined identifiers, then render scene with user defined identifiers, then re-enter normal render mode. Again after that, again you after rendering, again re-enter under normal render mode. This operation returns number of hits. Right? Then examine contents of name buffer, hit record. Then examine the contents of name buffer, because whatever records your selection area, those hit records will be in a name buffer. Then examine contents of name buffer one by one. Hit, that is hit record includes ID and depth information. Hit record includes ID and depth information. This is the procedure we have to do whenever we are using the selection mode, right? Example here, one short example is there, we will discuss that. That is wide mouse, int button, integer state, integer x, integer y. As I told, I am using a select picking by using a mouse. Means I am using to pick some area of my monitor, I am using a mouse, right? That's why I am interfacing a mouse, right? That is how to interface mouse. As I told, always mouse returns 4 parameters. One is a button, then one is a state, and 2 are x, y coordinates, right? Then GL init name buffer size, initialize the name buffer, because all hit records will go into name buffer. GL init hits, the number of hits, you have to count the number of hits, that is the one variable I require. Then GL viewport 4, GL I want viewport, always viewport has a 4 parameters, right? That is bottom left corner, then right top corner. Always bottom left means x min, y min, x max, y max, right? Those are, that's why viewport parameter 4. Then if, now I have to use my mouse, if button equal to glut left button and state equal to glut down. If button equal to left button, mouse left button, and state equal to down, initialize the name buffer. Then you start selecting GL init names, GL push names, push the names one by one, initially 0, then GL select buffer size, name buffer, then GL select buffer size, then name buffer, whatever buffer you have initialized here, name buffer you select this name buffer, then size, GL select buffer size, you select the size of the buffer, then name buffer, right? Then next, then set up a viewing for selection mode, then set up a viewing for selection mode, right? This GL jet integer argv, that is GL viewport means it will set the viewport for your viewing. It will set the viewport for this viewing, for this viewport, this will return the viewport parameter, that is 4 parameters it will return, that will be set by this viewport, right? Gets the current viewport, it will get the current viewport, then gets the current viewport, that is GL matrix, GL model, GL projection, then save the original viewing matrix, whatever originally you are viewing, entire monitor you may be viewing, save that original, that is a push matrix, then load identity, right? Then set n cross n, pick area around the cursor. Now you have to select n cross n pick area. Means for example, if you are selecting, for example, if you are selecting this one, only if you are selecting photos on this screen, you have to set only for this viewport. Now in your viewport only you have to see that photo icon. The entire icon should not be displayed on your viewport because you are only concentrating on that. That's why you see we set that one, n cross n pick area around this cursor. That how to set. There is a GLU pick matrix. There is a GLU pick matrix. API is available. GL X, that is minimum X, then minimum Y. This is minimum X, this is minimum Y. As I told, always viewport has X left, Y bottom. Means bottom left corner, that is the X value, you want Y value. As I told, Y value you have to invert. Y value has to be inverted. Always means height minus Y. You have to do height minus Y, then only you will get the proper input, because OpenGL takes origin at bottom left, but mouse returns origin from the top left corner, right? To that we have to invert that one. While in explaining that locator device, at that time I have told. That's why viewport 3 minus Y means you will get proper X and Y coordinates with respect to OpenGL, that is origin at 0, 0 at bottom left corner, right? Then n cross n, which is n cross n is exactly center, means it is a n cross n pick n cross n pick area around a cursor. Means around your cursor you have to select the pick area with viewport, whatever viewport you have mentioned previously, right? Then next, same clipping window as in the reshape callback. The same clipping window as in the reshape callback. Glut GLU ortho 2D, X minimum, X maximum, Y maximum, GL draw objects. Then GL draw the objects from by taking from name buffer one by one by using the select GL select constant, OpenGL constant. Then GL matrix mode, GL projection. Then restore the viewing matrix. Means whatever original viewing matrix is that you restore. GL pop matrix, GL flash. Then return back to normal rendering mode. As I told, normally you have to return back to normal rendering mode. Once you come normal rendering mode, then only it will render give the hits, number of hits, right? That hits equal to GL render mode, GL render. Then next, process hits from selection mode rendering. Then your all the hits are there in your name buffer. You take one by those hits, process hits, that is hits comma name buffer. How many hits are there? Those hits will be there. Then name buffer contains all the hits, right? Normal render. Then GLU post redisplay, right? Then draw those, as I told, this user defined function I used them. Then GL under mode, that is GL if mode equal to GL select, then load name one, then color. Like this you start rendering one by one all the hits in your name buffer, right? Here we have taken 2, 1, 2, that we are rendering here. Then process those hits by using this process hits, again using right here code how to process those. Then as per that you can draw hits, right? Then next is animating interactive programs. Animating means we have drawn till now, we have drawn still pictures in only during lab. I think you have seen one spinning cube. Spinning cube is an animating program. Right? Means we have given a feel of that object is rotating or that object is moving, right? Those are not a still picture. Those are called animating interactive program. Means you have to do something, the objects are moving automatically, then you feel that the object is moving, right? That is called animating interactive program. For example, in that spinning cube, same logic we have used there, right? For example, you want to rotate one object. For normally the points x equal to cos theta, y equal to sin theta always lies on a unit circle regardless of the value of theta, regardless of the value of theta, right? Then here the points x is cos theta, y is sin theta. We are derived when rotating that rotation in 2 dimension, right? Regardless of the theta value, right? In order to increase the theta by a fixed amount, means you want to rotate that x and y, because you want to rotate around whatever x in clockwise or anti-clockwise, you want to rotate. That's why you have to increase the theta value. In order to increase theta by a fixed amount, whenever nothing is happening, we use the ideal function. Means a call display function, callback function we have used, call display function, callback function we have used, right? GL function, GL display func, right? GL display func, we have GL display function we have used for callback function, right? Means whenever you do something on your monitor by pressing mouse and all those things, at that time it will activate its event. But in some of the case, you, in spite of pressing anything from my keyboard, for my keyboard or for my mouse, but there is a change in my monitor, means output device. There is a change in my output device. Continuous there is a change, because for example first object is displayed at cos 30 sin 30. Then next time I may be displaying object at an angle cos 40 sin 40. Next time I may be displaying an object at cos 50 sin 50. Like that means in spite of in this process we are not touching any of the hardware part, right? In that case, but our object is, means every time the position of our object is going to change. In that case I have to control my monitor. That case also we have to control our monitors, right? Then how to control the monitor without pressing, without invoking any hardware? In that case we have to call ideal function. There is an ideal callback function. In ideal callback function you write this code, then call, register that ideal callback function. If this ideal callback function will take care of such situation, means nothing you have been pressed from the hardware part, means there is no event from the hardware part, but there is a change in output device. There is a change in output device. At that time we have to make use of this ideal function, callback function, right? For that reason we have to write that in ideal function, wide ideal, right? That program we are writing theta plus 2, means I am incrementing every time theta by 2 angle, right? Then if theta greater than 360, then theta equal to minus 360 I will do. Again I will set to 0. Again I will continuously I will rotate. If you observe that program spinning a cube, continuously it is rotating, means it will go to 360. Once it reaches to 360, again I will assign to 0. From 0 to again 360, again 0, 0 to 360. That same thing we are doing here. Every time I will increment theta by 2. As and when you every time you increment theta by 2, automatically it comes to 360. Once it comes to 360, it will stop, but you don't want to stop that one. That's why again you assign theta equal to 0, then again add 2, again it will come to 360, again assign 0, again add 2, like this. Then glut post redisplay, then it will redisplay that object, right? Then here, in order to turn the rotation feature on and off, again in that program we are using continuously it is rotating. By default continuously it is rotating, right? Then if you want to turn it off and on by using again a mouse, right? Means animating, we are animating our program, means if you see that rotating pin continuously it is rotating, but if you want to turn it off, rotation you want to switch off, at that time again you can use a mouse, and by using a mouse some key use, if you press that mouse key then it will turn off. If you don't want to turn off, then you don't press, right? It will like that. That can be implemented, right? In order to turn off the rotation feature on and off, we can include the mouse function as follows. For example, if you want to use turn on and off, right? At that time you can use this, right? What is that? Wide mouse integer button, integer state, integer xy. If button equal to left button and state is down, left button if you press down, then glut ideal, function ideal, then rotate. It will call the ideal function, it will rotate. It will call the ideal function, it will rotate, right? If you press down, right? If right button, then use right button and glut down, means use the right button, glut down, glut ideal null. At that time you stop. That time you stop. Glut ideal function null. At that time it will not call, only it will call the null function. It will stop that one. Like this you can interface. It can develop animating programs. This is simple animation program, right? In that spinning a cube we have done this one, right? We have done this one. As like this normally we will interface, means when you are doing this one, you know most of the APIs available in OpenGL, then how to interface hardware and all those things, right? This is what animating program. Then next comes in OpenGL logic operations, right? Next concept is logic operations. Normally whenever you are rendering any object on the monitor, normally that means rendering is nothing drawing. Rendering is nothing but drawing. Means drawing is nothing but what? We are making that particular pixel on or off. Particular pixel on or off with the colors. Particular pixel on and off we are making with the color. Whatever color of that source or whatever object so color is there, that color will draw there. If the object is in that pixel, if that object is not in that pixel, then switch off that pixel. That is what we are doing. Then how this will happen? The final operation on the fragment is the logical operation. Final operation on that particular fragment or particular pixel is a normally logical operation, such as an OR, XOR or NOT, right? Which is applied to the incoming fragment value, that is a source. Incoming fragment value is a source, and or those currently in the color buffer, that is the destination. Means source color, destination color will be applied logical operation, then the result of logical operation will be affected on monitor normally, right? There are some logical operations are there, we will see those, right? This is what happens when you are going to display it in a monitor, right? Means source input, source color, destination color, you apply the logical operations, whatever result you will get, normally that color object you will see it on that pixel. Every pixel by pixel it does, right? Then such fragment operations are especially useful in bit-plate type machines, means in OpenGL, in computer graphics bit-plate machines it is applicable, on which the primary graphics operation is copy, means primarily by default it copies, means whatever source value is there it will copy on that source, right? Whatever source is coming, that source is copied normally. If it is a red color pixel you will feel, if it is a blue color pixel you will feel the blue color. That is a copying rectangle on a data of a data from one place in the window to another, from the window to processor memory, or from memory to window, whatever, right? That will be done normally copy. Then typically the copy doesn't write the data directly into memory. Typically the copy doesn't write the data onto the memory, but instead allows you to perform the arbitrary logic operations on the incoming data, and the data already present, and the data already incoming data and data already present, you can apply the logical operations by using a copy, right? By using a copy, right? Then it replaces the existing data with the result of the operation. It replaces the existing data with the result of the operation, whatever operation if you have done, or XOR, and whatever operation you have done, incoming data and available data. Incoming data means destined color buffer and incoming source data, it will do the logical operation. Then whatever result it gets with respect to that result, that part of that pixel will be affected, right? You enable, for doing this one you have to make use of that operation, that feature in your OpenGL which is available, right? It is by default it is not enabled, right? To do this you enable and disable logical operations by passing. You can enable and disable logical operations whenever. If you want to use logical operations you have to enable, if you don't want to use you have to disable. How to enable? GL enable GL underscore logic underscore operation, GL enable GL underscore logic underscore operation also enables logic operation in color index mode, means this you have to enable, then only can use for logic. You can use your OpenGL for logical operations. By default it is not enabled. If you want to use logical operations in your program you have to enable this one. Then after your work is over, then you can disable. Right? Then how to use logical operations, then which API is available for using logical operations. There is a API available, wide GL logic operation, there is a wide GL logic OP, GLNM opcode, which logical operation you want to use, whether you want to use XOR, OR, and all those things, those are in below table, those are given. Then select the logical operation to be performed. This will select the logical operations to be performed given an incoming source. It will perform the logical operations taking incoming source as one input fragment and the pixel currently stored in the color buffer, one input from the incoming source, one input from the destination buffer. You do the logical operation on the incoming source and the destination buffer, right? Then whatever result you will get, that result will be affected on that particular pixel, right? There are 16 logical operations in OpenGL. You can perform different 16 logical operations in OpenGL. The default value is GL copy. By default for GL logic operation, default value is GL copy, right? Then parameter operation we have given. For example, there is a parameter opcode for logical opcode GL clear. If you are using a GL clear, then operation will be 0, means it will clear everything. If you use a GL copy, source, whatever source is coming, as it is source will be copied there. Means if source is a red color, you will see the red color pixel. If source is a green color, you will see the source is a green color, right? Like that. That is a copy. Then GL no operation, that is destination. Whatever destination input value is there, if destination is in red color, only destination color will be displayed there. If destination is black color, destination color will be monitor it will be black color. That is NOP, GL NOP, right? GL means how to use that one. GL logic operation, GL here, GL logic operation here you have to use GL NOP. If you use GL NOP, then it will return destination as it is, right? Then if you want, you can GL and source and destination, whatever result you will get, that result will be affected on that particular pixel. Then GL or source or destination, then result of this will be red and blue. If the red and blue are there, then result of red and blue will be displayed on that, right? Then GL NAND, S and D NAND, then combination of that NANDed. Color means source color, destination color, you do the AND, then you do the AND operation, that will be affected there. Like that. GL set, always all colors will be set with 1, right? GL copy inverted, like this there are 16 operations. GL NOR, GL XOR means S XOR destination, source XOR destination, source or destination not NOR, right? equivalent, right? This is what GL NAND inverted. These are total 16 different type of logical operations you can perform by using these constants, right? One example we will see. How to use XOR. Example we will see XOR, right? This I'll, before going to that example, I'll show one. This is what a rubber band effect. How to implement rubber band effect by using OpenGL program. Rubber band effect is nothing but this. What means rubber band? If you go to paint, here there's option rubber band. For example, now I'll take that icon, then I'll press my mouse, I'll drag this, then I'll do. This is what is happening here. This is called rubber band effect. Means I have drawn, means one edge is fixed, one edge is up, this line is fixed, other edge, as and when I move my mouse, the line also is moving, right? I can increase, I can decrease the size of line, right? I can rotate. This is what rubber band effect. Then how to implement this rubber band effect in OpenGL, right? You can take a line, or you can use this circle, whatever. This also, no, you see, this is what rubber band effect. As and when you start, one end is fixed, other end you can move how you want, right? These are all rubber band effect. Any object you take, this is what rubber band effect, right? This is a rubber band effect. Then how to implement this type of features in any of the application, that is what rubber band effect. Then that we are implementing by using logic operations, that to XOR, right? By using logical operation, that to XOR. How we implemented, we will go to that program, then I'll explain that this concept I will explain by taking that program as an example, right? Here you see, this is our program. Here hash include GL everything, right? Then GL x minimum window, then window port size, everything I have taken here. Window size integer, first one variable we have taken first equal to 0, then my init void, then I will set viewport, left bottom column is 0 0, right top column is WWHH, means my window size is 002, means viewport size 002, 500 comma 500, then GL matrix mode, GL projection, GL load identity, right? GL ortho means 2D, we are doing it in 2D, that's why left, right, bottom, top, HH, right? That is means left, right, bottom, top, right? This we are given. Then GL matrix mode, GL model view, then GL color, I will set background color, all those things. Then GL mouse. Now I am using, because you have to use a mouse in this case. I think you have seen in that paint. You have seen in this paint, means I will press one button. If I take this line, I will press here, then I will hold. You have to keep on holding this one, right? Then drag. Then you change your mouse, right? Still I have not left the mouse. Then by pressing that mouse I am rotating. By pressing, still I have not released. Once I release, then line is fixed. Afterwards you cannot move. Once I release, that line is fixed. Afterwards you cannot move, right? This is what rubber band effect, that we are implementing in this. Right? This. Then here what we have done, then that's why I am using a mouse. As I know, mouse always returns 4 parameters, that is a button, that is a state, integer x and y coordinates, right? GL color, then you select one color for this drawing. I am selecting one color for this drawing, that is red, right? Then GL if button, left button, I am using again left button for drawing this one, left button, and state equal to glut down, means if I press down, then you have to do this action. First point, means first point I am drawing. If you see this one, first point, now I'll press left button, then down, right? Then first point I'll draw. Then second point is this. Actually this is second point, right? That I am drawing here. Then second point, that is the first point, where whatever x and y is written by mouse, here mouse will return this x and y. Mouse will always return x and y. Take that x into xm, ym equal to 500 minus y, that I have told. You have to invert, because if I press somewhere here, my mouse will return this coordinate, but I want OpenGL will take that here, inversion. You have to done inversion, because my height is 500 here. I have taken height 500 minus whatever y has written by my mouse, I will subtract. Then I will get normally OpenGL coordinate, that 0 0 is here, 0 0, that we have done here. Then GL logic operation I want to use XOR, GL logic, OP, XOR. XOR we are doing by this rubber band method, we are implementing by XOR logical operation, that is a XOR, right? Initially first is 0. Initially first is 0. If I draw left, if I press left, then button is down, then I will draw first point by using XOR. I will draw first point using XOR, whatever color is that color, whatever this color, right? That is first is 0. Then afterwards, if button equal to glut left button and state equal to glut up, then that is the final button. That is the final button. You can see, right? If start here, then if you release, this is final. Afterwards you cannot rotate. After once you release the button, then this is final. This is second button, second point. This is second point, right? That is after releasing. Normally after releasing, that we are implementing here, right? Then glut left button, same glut left button and state equal to up. That is the final point. Then glut again same color. Then logical. There you copy. Use logical operation GL copy. GL copy means source as it is you copy, right? I'll tell why this. Then x minimum xmm equal to x ym equal to again negate. Then GL begin, GL line, GL vertex xmm to YMM. Then GL means you start at final line. You start here, then till this you draw by using a copy. By using a copy means directly source, whatever source color is there, with that color you copy this, right? As I told, copy means it will directly copy the source color. With the copy, you copy the source color, right? Then only after releasing, right? Then GL and GL flush, right? Means this is starting button, this is the end button. Only end button will do the copy. Only end button will do the copy, right? Then it will start at first point and it will draw till last point, right? Then if button, right button and state equal to glut down, then exit means if I press right button, then I will stop this program. Here you see how that is implemented. Wide GL draw line, integer x, integer y. Wide draw line, integer x, integer y. Here from integer x, integer y I will get whatever my mouse has written, integer x, integer y. If first equal to 1, first time first is 0. First time first is 0, right? Then it will come directly here. X minimum equal to x, y minimum to y, 500 minus y, right? That I will convert into this. Then I will begin GL lines, GL x minimum xym, then vertex x minimum xym means till that last point, because always xmm xym I am getting from this. Initially they are both are same. Only when I start changing, at that time those values will start changing. They will come here. Then I'll start drawing. Then I'll draw the line. Then GL end. Then GL flush. Then first equal to 1. Then if first equal to 1, then what happens? GL lines, GL row, right? What happens here? Logical XOR I am doing. XOR means we are drawing 2 times. That line is drawn 2 times. This logical XOR, how it works? Logical XOR, clear and copy. It does. Here what it has to do, you see, observe. You have drawn this line like this, right? You see line is from that point to this point. Then you will move slightly. What has happened? Previously your line is visible in this here, means your line is visible from this point to this point, If slightly if I change, means one more line, if I take here, if I change this one, right, line position will change. Means previously line was somewhere here. If I change that position, that line will go, that line is erased, then new line is drawn continuously. Means what is happening here? If I do means every time previous line it has to erase, it has to draw new line. Previous line it has to erase, it has to draw new line. Previous line it has to erase, it has to draw new line. As and when I start rotating, it has to erase the previous line, draw the new line from one fixed point to one changing point. This is what it is doing actually. In this case, what I am doing here, actually XOR we are doing like this. 2 times we are doing XOR. Source XOR destination XOR source. Source XOR destination XOR source. That we are doing here. That's why if first equal to 1, what happens? First will become 1. Then first equal to 1, condition becomes true. Then I will draw. Again I will draw same line, right? Source, destination, source, a source, destination, source. If you draw two times, then what will happen, right? Source in XOR, if two inputs are same, then you will get again, what you will get? You will get 0, right? That means if you get same color with one more time, if you draw same color with one more time, automatically it goes, it will vanish. That we are doing here, right? If first equal to 1, then again I will draw, then I will come here, means old line I will draw one more time, means S XOR S. Only XOR is 1 when XOR is 1 if inputs are dissimilar. If inputs are similar, then XOR is 0. If inputs are similar, XOR is, that's why already I have drawn that line with black color. Assume that already I have drawn that line with black color, right? Then now first is 0 here, still I am in this only, first is 0, then again I will check if first equal to 1, because I am not, still I have not released my mouse, if first is 1, yes, first is 1, again I will draw. But what color I am drawing? Again still I am drawing with a black color. Where I am drawing? On same line, x minimum, y minimum, x minimum, y minimum, on same values I am drawing, on same x and y value I am drawing. Already I have drawn with black. Again one more time if I draw with the black, then it will erased, automatically it will erase. Then I will come here, then new x, new y, then I will draw new, again with the black color, means nothing but what we are doing, previously drawn line we will erase, then we will draw next line from first point to second new point I will draw, then I will repeat this one, this will be repeated. First initially you draw one line, right? Now I draw, now this line is visible, then again first is 1, still you are not released your mouse, still mouse you are rotating, then again it will come here. If first is 0, first is 1, yes, now second line you have drawn, again you draw second line one more time, then that will be erased, then new line will be drawn like this, means as I told, right? First I will draw this line, then slightly I will change, first I will draw this line, right? Then slightly I will change like this, here, means I will draw one more line, like for example like this I have drawn, right? Means I am rotating in this way, I am rotating like this, in this way means firstly I have drawn like this, then my mouse is here, I will rotate, then slightly, means every time new line in a circle, every time it is drawing a new line around every time it is drawing a new line, it will erase the previous line, it will draw new line, erase previous line, draw new line, erase previous line, draw new line, erase previous line, draw new line, like this. This is we are doing here. This what it does, if you draw one more time with a black color, automatically that will be erased, then draw the new line, again go back, this is a new line, again you draw on same line, again that will go, again you will move right next to that one, like this we are repeating this one. Here we are doing that one, right? Means XOR source, XOR source, you will get 0, again source XOR destination, you will get new line, then you repeat this one until you release the mouse, once you release the mouse it will come out. Once you release the mouse, you will then display GL color buffer width, GL line width also you have set. That is what this is single glut RGB, glut window size, glut create window, minute, glut mouse function, because you have to register, because I want to use the mouse here, that's why glut mouse function, mouse, then glut motion function you have to use. Here one more function you have to use, glut motion function, because every time your mouse is doing motion, right? That motion function, draw line is in motion function, draw line is in motion function, right? Means until unless you will release the mouse, this motion function will give you the input, always new x and y. Motion function will take the new x and y, then it draws, old it will erase, new it will draw, old erase, new. How we are erasing? If you draw same color with the 2 times on a same dot, if you draw same color 2 times, then automatically it is, because you are using XOR, right? You are using XOR. If both the inputs are same, then automatically it gets 0. Only if you will get input 1 if both inputs are different, right? It is happening in this case, right? Then glut motion function you have to use for this, glut motion function, draw line, then glut display function, display, then glut main loop. This is what the rubber band effect. If you execute this program, then you will feel that yes, you have done rubber band effect, right? Use mouse, then you will get that one, right? This is about the logical operation. One logical operations I have explained here, Like this you can use any logical operations, like that you can use it in your program, then you can see the outputs, right? This is today's session, right? This completes input and interaction. In next session onwards we will start with curves, that is Bezier curve, spline curve, all those things, right? Thank you.